Hello everyone, welcome back to the solutions for the free response questions for the AP Calculus exam. These are the questions from the 2024 paper. Alright, now question 4 might look a bit weird because the graph is of a function that is not explicitly stated, right? Only the shape of the function is given. You are given the function in the first quadrant as well as the second quadrant. It's given from -6 to +7. Alright, at -6 the value of the function is 0.5. At +6 the value of the function is -1. Okay, it's also given that the area of the shaded portion R is 12. Now the area of the shaded portion is bounded by the y-axis, the line x equal to -6, and a curved portion. Okay, while it is given that the entirety of the function in the first quadrant is linear. Okay, you can see the second statement in the description of the problem, which says that the horizontal tangent at x equals to -2 and is linear for 0 less than x less than equals to 7, which means in the first quadrant the function is linear. This will be helpful when we are solving subpart C of the question. Alright, now that you have understood the problem, hopefully we can move on to the first part of the solution. It says that the function g is defined as gx equal to, alright, so let us look into what the function is defined as and then we can solve it. Let's see what the function is defined as. Here, subpart A, g is defined as g of x equal to 0 to x ft dt. Okay, so g of x is basically the integration of the function. Now integration, as we know, is defined as the area under the curve, right? So we are supposed to be finding the area of the curve. Fine, let us calculate. Find the values of g of -6. Now g of -6 can be defined as, just putting the value of x equal to -6, it's 0 to -6 ft dt. Okay, 0 to -6 ft dt will be the area under the curve, right? Now 0 to -6 is the same as negative of -6 to 0, isn't it? We would be going from the lower values of the integral in the lower limit to the upper limit, but here the lower limit is more than the upper limit. That should not be the case, right? So we will reverse the integral. It's very easy. We will just do a negative here and then put -6 comma 0 ft dt. Now what does this say? This says that the area of the curve from x equal to -6 to x equal to 0, which is the y-axis. Now notice -6 to 0, that is the region R, right? So the area of that is given to be 12. So it will be 12. Alright, no calculations necessary. The marks allotted to this particular subsection was contingent upon you realizing that you would have to adjust this integral by a negative sign. Alright, so do make a note of this important step. Here is where the marks were contingent. You cannot skip this step and write -12 directly. That will result in a loss of marks. Okay, so g of -6 is equal to -12. Fine, let us look into the next part. The next part is g of 4. Now here we do not have to reverse the integral, right? Because this is 0 to 4 ft dt. Now 0 to 4 ft dt, in the first quadrant ft becomes a linear function, right? So 0 to 4 we can clearly see that this is a triangle. If we name these positions A and B, let us name these points as A and B. So AOB becomes a triangle, and AOB is a right angle triangle because the axes intersect at right angles, isn't it? So I can calculate the area for right angle triangle as half base into height. So this is basically half into, what is the base here? 4, and the height is 2, so this is 4. Alright, g of 4 is 4. Fine. Now we have to calculate g of 6. Now g of 6, here the linear function goes below the x-axis, right? So we would have to not only calculate the area of AOB, but also we would have to calculate the area of this triangle. Okay, let us name it as C and let us name this point as D. So AOB, and then we have to adjust the area by BDC. Now we will not add the areas because one is on the positive side of the x-axis, the other is on the negative side, which means the other one, that is triangle BCD, is in quadrant 4. So we will subtract it. Alright, so g of 6, right? Yeah, g of 6 is basically 0 to 6 ft dt, which is this g of 4 again, this triangle I am writing it again, half into 4 into 2, and minus again BCD is a right angle triangle, so minus 1 will be the value there. So although the coordinate is minus 1, we know that the distance is 1, isn't it? So it will be half into 1. We'll not write minus 1 because minus 1 includes the direction of the coordinate. Since we are using the formula base into height, those quantities cannot be negative. Even if they are in the negative direction, we are adjusting it by the negative sign outside the formula. Okay, so half into 1 and this is 2. So 4 minus 1, which is 3. Okay, so g of minus 6, g of 4 and g of 6 are calculated. Very easy. They were just the areas of the graph, which one of which was actually given to you. Region R was said to be 12, and the others were just applications of formula of triangles, which we had learnt in plane figures, the chapter. Okay, basics of geometry. All right, second portion. For the function g defined in part A, find all values of x in the interval 0 to 6 in which the graph of x has a critical point. All right, so g of x is the same function as before, 0 to x ft dt. Now how do we actually calculate a critical point? I hope you remember. Again, I would just remind you all that critical points, inflection points, turning points, all of these are the same things. All right, now we calculate a critical point by setting the derivative of the function to be 0, right? And then we check if the critical point is a maxima or minima by using the double derivative test, or we can use the points that are very near to the inflection point. If such values of points are given, we can check via that also, the direction of the tangent immediately after and immediately before the critical point. Although I prefer the second derivative method, you can do it in either way. Alright, g of x is given to be 0 to x ft dt. Now we would have to calculate g dash x. Now if gx is the integration of ft dt, clearly g dash x would be equal to fx, right? That's from the basic principles of calculus. If gx is the integration of something, then the differentiation of gx will be something, right? The integration sign is technically the antiderivative, so derivative of antiderivative is the normal function. Alright, so g dash x is fx. Now critical points of gx will just be the points where fx intersects with the x-axis. So critical points of gx are the roots of fx. Okay, so we know that whenever a function intersects the x-axis, cuts it from below, touches it, does not matter, as soon as it intersects the x-axis, you have one root. So where does it do it? Cuts it once, right? So the intersection point will be at 4, 0, and the critical point is x equal to 4, right? 4, 0. Let us write it down. Therefore critical point is at x equal to 4, or you can write 4, 0. Same thing, right? X equal to 4 means 4, 0. I hope this is clear. The question was seemingly a bit tricky, but once you write the first line, that should be clear to you, because you are taking the derivative of an antiderivative, so you will get the original function back. Alright, the next one. The function h is defined as hx equal to minus 6 to x. Fine. Okay, 3 values are to be calculated. Let us do it. So h of x is given to be minus 6 to x f dash t dt. Alright, so if h of x is given to be minus 6 to x, we would have to calculate the value of h6, h dash 6 and h double dash 6. Okay, so let us calculate h6 first. So h6 would be minus 6 to 6 f dash t dt, which is basically f6 minus f minus 6. right? That is how integrations are done. F dash t dt is integrated to be ft, and it is to be evaluated at 6 and minus 6. So what is f6? F6 means the x coordinate should be 6 and we have to calculate the y coordinate, because y is the dependent variable, right, and x is the independent variable. So coordinates of a function are x comma fx, or if we set y equal to fx, then it's x comma y, right? So if it is x comma fx, then at x equal to 6 we would have to calculate the y value. At x equal to 6 the y value is minus 1, and at x equal to minus 6 the y value is half. I hope this is clear. We just used the principles of definite integral and then put the values according to the graph that was given. Okay, do not be afraid of the calculations. It will look a bit intimidating, but just open it up and things will seem easier, because the exam is not very difficult in terms of mechanics and calculations. It also tests your comprehension skills, whether you understand the scope of the question, how is it related to the graph that is given, and the implications of it. Okay, you are supposed to learn the techniques of calculus not just for solving random problems, but also to solve questions that have some context to them. Okay, that is why the seawater question was given. We had a question on Newton's laws of cooling, etc. All right, something that relates to some real world problems. All right, now next portion is h-6. h-6 is basically the slope of the function at 6, right? Because h of x is the integration, so h dashed of x will be the normal function, right? H dashed of x will just, if h of x is the integration of f dash t, then h of x is basically fx, and h dashed of 6 will be f dashed of 6. I hope you catch the drift. I'll explain it again. H of x was given as the integration of f dash t. Now the integration of f dash t is ft, isn't it? Or whatever the value of definite integral that is given to you. Here it is minus 6 to x. Now if hx is equivalent to fx with certain stipulations about the definite integral, then h dash of x will be equivalent to f dash of x. So h dash of 6 will just be f dash of 6, right? Now f dash of 6 is the slope of fx at x equal to 6, right? Now fx in the first quadrant is a straight line, isn't it? Linear. Okay, so slope of fx, that can be calculated as y2 minus y1 by x2 minus x1 if fx passes through x1 comma y1 and x2 comma y2, right? This is a formula from coordinate geometry which you have learned, hopefully, the basics. Now slope is given by m equal to y2 minus y1 by x2 minus x1. Now we would need two coordinates through which fx passes. Those are clearly with us, a and b. B is 4 comma 0, so I'll write them down. This will be a and b, right? So b is 4 comma 0 and a is 0 comma 2, right? So the slope will be now y2 minus y1, so 0 minus 2 by 4 minus 0, which is minus 0.5. Okay, I hope you've understood. This question tested you on all the foundations of calculus. What is the meaning of integration was tested in the first problem, where you had the area calculations. The second one tested whether you understand that derivative of an antiderivative is the function itself, and the third one tested the same concept, derivative of antiderivative is the function, and then the derivatives of that function, what does it mean? It means the slope. And now we will see the second derivative. Now for a vertical line, or let's not say vertical line, for a linear shaped curve, you will get a slope, right? You will get a value of the derivative because you can calculate y2 minus y1 by x2 minus y1, but then the slope of that line, that will be constant, isn't it? Because this value will never change. As you keep extending the line, you will get different points, but the slope of the line will remain the same because it's linear, right? It's not curving. If it is not curving, then the slope will remain the same. And now the derivative of a constant, that will be 0. So I can just write h double dash x at 6, right? So h double dash 6 equal to f double dash 6 equal to 0, because f dashed 6 is minus half and the derivative of minus half will be 0. Alright, I hope you understood this problem. This was a very fundamental question. There was no ifs and buts about it. They just asked you all of the basics of calculus in one question. Basics of integration, first one. The relation between integration and differentiation in the second one. The relation between integration, differentiation, first derivative and second derivative in the third one. Alright, so if the basics are clear, this one should not be a problem. You do not even need to identify the function. Every value is given to you. You just need to look into the graph and infer what the values should be. Alright, so if you do want to explore the basics of calculus with us, or if you need any help in this regard, do not hesitate to contact the number that is given below my face panel. You can drop a WhatsApp there, our team will get back to you. If you do have any comments, suggestions or feedback, do not hesitate to drop them down in the YouTube comment section. You can also get in touch via the contact details given there. Alright, I'll end this video here. We will meet again in the next one, and there we will be discussing the last problem of the free response questions in 2024. That's it. Take care, and I'll see you all in the next one.